In this video, I'm going to look at the formula for calculating the area of a triangle and give you an example, and then look at why this formula works. There you can see the formula. That's all you need. The area is equal to 1/2 the base times the height, and that can also be written 1/2 b times h, where b is the base and h is the height. It's very important that you get the dimensions of the base and the height correct. The base dimension is the length of this line here, where if the triangle was sitting on the bench, that would be its base. And the height is not the length of either of these sides. That's not the height. The height actually goes from the apex to the baseline vertically. So we've actually got a right angle here, and this is the height. So don't use the side length unless it's a right angle triangle where you happen to have the height being the same as the side length. Otherwise, you've got to know what the height is. So as an example, we'll look at a triangle with a base of 10 centimeters, a height of 6 centimeters. So to calculate the area, we might write the formula first, and then we put in the values. 1/2, now the base was 10 centimeters, and the height was 6 centimeters. So we can do that. It's very easy. We can do it in our head. 10 times 6 is 60, and 1/2 of 60 is 30. So that's 30, and the units were centimeters. We've got centimeters being multiplied by centimeters, so the units are centimeters squared. Now we're going to have a look at why this formula is the way it is for 3 different types of triangle. And the first one is a right angle triangle. The easiest way to think about this is that the right angle triangle is simply half of a rectangle. So let me draw in the rectangle that it is half of. I've completed the rectangle with the red lines here. If we take this side as our base and this side as our height, well, we know the area of a rectangle is base times height. Base times height for a rectangle. And the line, this line here, divides the rectangle in two. Therefore, the area of half of the rectangle, which is the triangle, is simply a half of the area of the rectangle, half of the base times the height. And that works for right angle triangles. In fact, this formula works for any shaped triangle, but it's not intuitive as to why that is. So next we're going to look at some other shapes of triangle, not right angled ones, and just check it works for those too. Here's the next shape of the triangle, not a right angled triangle. So how will we work out the formula in this one? So the first thing we do is we divide it into 2 triangles with a line down the middle. And we know the length of this line is the height. And we've got effectively 2 triangles here. Let's call the sides M and n. I don't want to use A and B because B is the base. So that's M and that's N. And these are both right angle triangles. So for the first triangle on the left hand side, as we've just seen, the area is half the base times the height, which is 1/2 n, that's the base, times the height. And then for the right hand triangle, we've also got 1/2, so we need to add this area, 1/2 the base of this triangle, which is n times the height, which is h again. And we can factorize this because they've both got 1/2 and h in each of the terms. So that is 1/2 h times m plus n. And m plus n is simply the length of the base, which we call b. So I can replace m plus n with b, 1/2 h times b, which if we just put these in the right order is 1/2 base times height as before. The last triangle shape to consider is this one where it leans over its base. So how can we apply working out the formula for this one? So we know that this is going to be the base. This is the base length, or B, and the height goes from the base up to the apex, which is about there. That's the height. Now what we can do is drop a vertical line down here to meet the baseline at right angles. Not drawn very well, but that's a right angle, and this is in line with the base. And now we've got two triangles. We've got one that is composed of these edges here, and we know the area of that one is 1/2 of its base, which is this distance here. We'll call that n. And with the other triangle, I'm going to do this in a different color so it stands out, is this red one, all the way to the end and up to the apex again. Got to get the hang of drawing on this thing. And we'll call the base for that one, I'll do this in red, n, right up to here. So for these two triangles, the area of the red triangle is 1/2 the base times the height, and that is 1/2 n times h, because that's its base. But that's bigger than the area we need. We only want this small bit. So what we can do is subtract the area of this smaller triangle here, and the area of the smaller triangle, so we're going to subtract that. The area of the smaller triangle is 1/2. I've called this m, so we'll just use that for the base. M times h. And again, we can factorize that. Take out the 1/2 and the h because they're common to both terms. 1/2 h, and we're left with n minus m. Now, if we take m away from n, we're left with B, the base of the triangle that we started with. So once again, we get half h times b, or b times h, doesn't matter which way round they go. And so we see that the same formula applies to triangles of any shape. And that's all there is to it. The area of a triangle is half the base times the height. Goodbye.